I don't like you.
All righty. Hopefully you line this guy up. Let's do it. We have x plus 2, and we have 8x cubed plus 6x squared. We got to have a 0x. Hopefully you caught that. We talked about that extensively yesterday. You need to have that 0 in there for missile one. If you don't, 2 lights out, not going to work out too good. All right?
That's why I got the wrong.
That's why you might have got the wrong answer. We're going to go with 8 here. X squared, because 8x squared times x will give us 8x cubed, and that's going to give us plus 16x squared. Remember, change those signs. So now we're looking at a 0 here, and that's what we want. Here we are going to get negative 10x squared. Bring down the rest of this garbage. Going to need to multiply by negative 10x. That's going to give me negative 10x squared. And then I'm going to have minus 20x. Of course, we have to change that sign again. That becomes plus and plus. So I'm end up with 20x minus 7. End up with 0 here. Again, that's what I want. Probably 20 will work. 20 times x would give me 20x. 20 times 2 gives me 40 plus. But of course, the signs need to change. Minus, minus. So I'm looking at negative 47. Is that right? So we end up with negative 47 over x plus 2. So, how's my math? Did anybody get close to that?
Yeah,
I got positive 47.
I got the
I feel like something's wrong with my.
No, I just think
Oh, well, there is. It's a problem. I did mess up. Hang on.
I got negative.
Well, this is positive right here. This 7 is positive.
yeah, it was about that.
Yeah. So it'll be plus, oh.
So it's going to be negative 33, in fact. Is what it is.
Yeah, okay, so. Maybe negative 37 is. 33.
Nice.
It's at 37, like, good.
Well, like I haven't. I just
The key.
7.
Stop. All right. Any of the problems from last night? I made a little simple guy there. We fixed that. Anything there? Yeah, thank you. All right. Today we're going to do synthetic division. You're going to like it. Much, much easier. I wouldn't write much of this down. I'm just going to do a problem. I think you'll just pick up on it. It's very similar. It's the same section. We're not going on. It's a simple way to do long division. Are you excited about that? You can go back and look at this PDF if you want. And you just keep repeating the same steps over and over. But I'm going to do one for you. And I think you'll find it to be not so bad. This is called synthetic division. It's a way to do long division without all the hassle, okay? So here we go. Step 1, you're going to take x minus 2, what you're dividing by, and solve for x. Solving here, we've taken plus 2 to both sides of the equation. So step 1, whatever I'm dividing by, I'm going to solve by it. It's going to make me a little half box, and put that in there. So step 1, solve for whatever I am dividing by. We're just going to use numbers in synthetic, which is very helpful. Now, I'm going to go look up and see what I'm dividing into. Is that in standard form?
Yeah.
Yes, it is. Do I need any zeros in there? Am I missing anything? So we're just going to write those lead coefficients. 3, 9, negative 2. And draw myself a little line there. So far, so good with the process. So we solve for the binomial we're dividing by. Then we look and see if we're in standard form. If we're fine, we don't need any zeros. We go straight across. Now, here's the fun part. First column, bring down 3. What's 3 times 2? 9
6,
times 6 is?
36.
I'm sorry, I said it.
Wait.
We're gonna add down. 9 and 6 give me
54.
15. We're not multiplying here, we're adding. 15, here's where we multiply. 15 times 2 is 30. Now you add straight down and get,
20.
okay. Now, what do those numbers represent? Well, those numbers represent the coefficients if we were to divide. What power is that? Power of 2. So we're gonna drop it 1 because we divided by x, so this is gonna be 3x plus 15 plus 28 divided by, what did we divide by? X minus 2. That's an easy way to do long division. Now let's see if it really does work. Let's try long division over here with this problem. So we have x minus 2. I have 3x squared plus 9x minus 2. So I'm going to need to multiply by 3x. That'll give me 3x squared. That's going to give me minus 6x. Of course, I have to change these signs. That becomes minus and plus, so I end up with 15x minus 2. That multiplied by 15. That's going to give me 15x. That's going to give me negative 30. Of course, we got to switch those signs. That's going to give me minus, and that's going to give me plus, so I'm going to get 28, which will leave me with plus 28 remainder over what I divided by x minus 2. Is that the same? Gosh, it is. So synthetic division is a much easier way. Why? Because we don't have what in there? We don't have all those x's in there. We don't have all those x's, and we don't have any letters, just numbers. So let's review the process again. Process step 1, we gotta solve for this, set it equal to 0. Okay, step 2, make sure we're in standard form and we don't need any zeros. Okay, we're missing half box, number, coefficients, add down, multiply, add down, multiply, add down, and that's it. Go for it, try. Half box is what?
2.
Not 2, but
Negative 2.
-2. Gotta solve. Now be careful, we're gonna need some zeros here, don't we? It's in standard form, but we're missing which term? We're missing the x squared term. Coefficients, 3, -1. Don't have x squared, we put a 0. 5, -1. Now, 3 comes down. 3 times -2 is 6, -6. Add. Negative times negative is positive. Add. Multiply. 14 times -2 is negative 28. Add. Multiply. Positive 46. Add. Now, what do those numbers really mean? Well, those are the coefficients of each individual spot. What's my highest power? What's the power I started with? X to the 4th, didn't I? So we're gonna drop it 1. So this is gonna be 3x to the 3rd minus 7x squared plus 14x minus 23 plus 45 over what I divided by. X plus 2.
Why do you have 5 terms, but there's only 4? Like,
Because one's a remainder.
Which were you talking about?
you have 4 terms in the 5 down there.
Well, I put 0 and put the x squared.
Oh, okay.
Is that, yeah, I think it's, okay. Hey, you like that? You should. Question,
So what's the first -1 from?
right here. Negative x cubed,
So you have to put a 0 with that?
because I'm missing the x squared, I don't have x squared. So that's what that is. Good? Okay. See what you can do, that one's pretty much easier. Synthetic division. Takes a little practice.
So.
Yeah.
So Mr. Greg, you multiply by -3.
Yeah, like a lot.
The real question is, like, what do you do after you set it?
You asking me that, or you asking yourself?
I know you
Negative 3 in the box. 6, -5, -6. Questions on setup? Anyone? First column just comes down, 6. 6 times -3 would give me -18, which gives me -23. That gives me a positive, and that would give me a remainder there. Now, this was the power of 2, so this is gonna be 6x minus 23 plus 63 over x plus 3.
So what do you do again with the, how do you get the, so you just move the first one down, right? And then you multiply the first one by that number, and that goes under the second number? And then how do you get the third number?
Same thing,
You just do that to the negative?
-23 times -3.
Okay.
Gives me positive 69. And this add down. Now, here's a side note. -3 is your x value, isn't it? Well, the remainder is your y value. So this is your xy coordinate. That's an xy coordinate every time. Which brings us to this next part, and that is the remainder theorem, okay? So basically what I'm telling you is if we do substitution, okay, synthetic substitution, it's just a little different. We really already solved. Look, I already have x solved for. I'm gonna do the same thing, okay? So I'm saying x is 2. What is your y value? Okay, well, we can do this substitution thing and get it really quick. So put 2 here. We already solved. Go down with my coefficients. 2, 5, -1 and 7. It's in standard form, don't need to put anything in there. 2 comes down, 2 times 2 is 4, gives me 9. 9 times 2 is 18, gives me 17. 17 times 2 gives me 34. That gives me 41, so guess what? If I were to plug in 2, I would get 41. If I were to graph this, this would be the x, and that would be the y. The remainder, whatever you have for x, the remainder will be your y value. Huh. You want more on that?
Yeah.
Let's try one more. This will be the last one. see if you can find, if I plug in, what would be the x and y coordinate? So the x, I'm telling you already, you wanna find the y value. If x is 1/3, what's gonna be the y value? What's gonna be the remainder? Okay? So what's going in the half box is negative 1/3. Am I gonna need any zeros in there? Yeah, I'm gonna. I'm missing what term?
The squared.
The square. So I'm gonna have a 6, negative 25, 0, negative 3, and 5. Remember, I'm just trying to find the remainder here. I don't need to put the x's in after this. This is synthetic substitution, not synthetic division. Division is where I put the x's in. Substitution, I'm just finding what is the y value for negative 1/3. In function notation, it would be find p, because that's the function, p of negative 1/3. What's p of negative 1/30? This is my x. What is my y? 6 comes down, right? What is 6 times negative 1/3 would be? Negative 2. Add straight down, I get negative 27, right? What's negative times negative give me positive? It's gonna give me positive
No.
9. 9 comes 9, 0 and 9 is 9. 9 times negative 1/3 would be
Negative 3.
negative 3.
So you're using
Gives me negative 6. Negative times negative is positive, so that's gonna give me a positive 2, which gives me 7. Now, what does that mean? Well, 7 is my remainder, so 7 would be my output if I put in negative 1/3. If I were to graph this polynomial, it goes through the point, negative 1/3, 7. Not the easiest to graph, but you could. I urge you to practice this situation, please. Questions, anyone? A couple of problems for you to do tonight, 19 through 27. Thank you for your time.
Yeah, I remember I'm not old school. We used to have